Hello, and welcome to 5-Minute Math. Today we are looking at the 4th grade concept of lines and line segments. This is standard 4.6a in the great state of Texas, and we are using item number 40 of the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we have this strange looking figure. We don't even need to know what type of shape it's called. We are simply looking for some line segments. So line segments are represented by just a little line like that. Sometimes you'll see little dots on the end, but more often than not you'll just see little line segments, and you might see like AG, and then you might see line segment CD. And really what we're looking for is, this is our keyword we've got to understand. So A, G, and CD, that'd be option F. We've got G, H, and J looking at different line segments, but we've got to figure out perpendicular. So when we are looking at lines and line segments, there are three terms that we need to keep in mind. We need to keep in mind parallel, perpendicular, which is what we're doing in this particular video, and then intersecting. And so we are looking at our line segments. These are the three types of interactions we can see with lines. So parallel lines never touch, and they're the same distance apart. And so think of them like two lines on a road. They just continue straight forever. And quite honestly, if you think of parallel right there, those are two lines. Pretend they never touch. They're the same distance apart. Honestly, I always think of the two L's right next to each other. The two lowercase L's right next to each other in parallel are parallel. Now, perpendicular form a right angle. So we can call that either a right angle. We can call that 90 degrees. Sometimes we'll even call that a square corner. But that's what we're looking for in this particular video, are perpendicular lines. One is straight up, one is straight across. Sometimes we'll see that little square put in there, but sometimes we won't. So it doesn't have to necessarily be like that. It can be like this, but it is a right angle. Think of it like a square corner. And the intersecting lines, they just cross. So I just think of lines kind of like an X. They just cross. They don't do anything fancy. They just intersect at some point. So let's take a look at line segments. Let's start with AG and CD, since that's the first one. So AG is right here, and then CD is way out there. Now they're both slanted, but I believe what they're trying to get us to see here is that line segment AG is actually parallel, and here is our symbol for parallel to CD, because if you were to extend AG and CD all the way up and all the way down forever, what you would find is that they are the exact same distance apart. They never get closer, they never get farther. So those are parallel, not what we're looking for. B, C, and CD. So here's BC, and we've already done CD. And take a look, they do intersect, but take a look at this angle right here. Does that look like a square corner? You have to kind of twist your head a little bit because it's not exactly vertical and horizontal, but that does look like line segment BC is perpendicular. So it looks like an upside down T with CD. So I'm thinking that's what we're looking for. Let's check the other ones. I've got DE and EF. So DE and EF, and take a look at this angle right here. It's an acute angle. It's not quite a right angle, so they just intersect. There's not anything fancy about that. They just intersect, so there's not quite what we're looking for. And then AG and FG, same thing. Here's your AG, but then your FG, they just intersect again. They don't do anything fancy, like they're not parallel or perpendicular. So we've got two sets that are intersecting, but what we're looking for is G.